be super honest to you guys. I don't even have a link for this. All I do every time I want to look up FRQs is Calculus AB. Look at that, free response. Oh, you can't see it, sorry. Calculus AB free response. Let me do it down here. Okay. Oh, it just pops up to the top. That's awkward. Can you not do it anymore? That's so weird. Anyway, I'm typing in Calculus AB free response. Now can you see it? There you go. Or Calculus BC free response. When you type that in, the very top one should be AP Central College Board past exam questions. Starting in the most recent year, you can see what the kids saw last year on Calculus AB because there's a 2000. What? Okay, that's weird. They're there somewhere. But anyway, the ones that show up first are the 2016. I don't know why it's not the 2018. But then you can keep on going back, and you're like, oh, you said all the exams, and this stops. Yeah, there's a whole selection of earlier than 1998. I think it goes all the way back to 1960. No, 1970. Anyway, it's been around for a long time. And there's a whole file of all the older ones, too. Long story short, if there are 6 different questions every single year, how many questions do you have to study from? Oh, a lot. Okay, let me go to the one that we're doing, which is 2007 Form B, wherever he is. There he is. Now, we see all sorts of different links. These are just the questions, like just the questions, question 1, question 2, question 3. In the olden days, you used to be able to use calculator on the first 3 questions. It was only, and they say a graphing calculator is required for some parts. So they should tell you when the graphing calculator is no longer required. Does it say stop? Perfect, no calculator. So on the older versions of the exams, you can tell which ones are calculator, non-calculator. Basically, it's the first 3, calculator, second 3, non-calculator. But this is the one that I showed you guys, but this is just the question, which is good and all, but let's go back to the page. These are the scoring guidelines. This is in some ways, shapes, or forms, even though the graders have way more detail and have like whole rooms assigned for a particular question of the AP, and the rooms are broken down into tables, and the tables all have leaders that were personally coached from the room leader, and the room leader was personally coached by the, anyways, this whole hierarchy to make sure it's as objective as possible in your grading. It's crazy how detailed they are and how much they've thought through the different answers kids give, etc. Because kids have practiced their questions in the past, because they give little like random questions here and there years before the actual AP they actually give it in, and see how kids do in sample sets, etc. But anyway, the scoring guidelines show you every single one would have 9 points. There's 3, there's 6, and there's 9. Every single one has 9 points given. Now, to some extent, it's easy to grade, and to some extent, it's hard to grade. Because remember how I said, like, even if, for instance, in this one, even if the kid had 1.546, if they wrote something wrong, like say they were silly and wrote a minus instead of a plus, even if they plugged it in their calculator right, guess what they wouldn't get? The answer point. Because they showed incorrect work leading up to that. You need to have a seamless, you need to have perfect work shown. You need to have a full and complete argument as to why you put what you put. So there are things that you might be like, I got it right, I got it right, I got it right. And they'd be like, oh, but we had to take a point off. Like if you didn't write dx. If you didn't write dx, if you didn't group with parentheses. Anyway, they could take points off. But anyway, all that to say, those are the scoring guidelines. But still kind of tricky because it's like, okay, if you know how to grade it and how they would grade, we could do that. Here's the next one. All 6 questions have this really cool document I'm going to show you that not only have the scoring guidelines, kind of like what the AP graders used, but also have some kid's actual exam answer. And not just one kid's exam answer. That's one kid. Another kid's exam answer. And another kid's exam answer. Guess what? They gave us a high, 9 out of 9, a middle, 6 out of 9, and a low, 4 out of 9, which, to be honest, 4 out of 9 is still pretty good. They put something. There's probably quite a few. And I've graded quite a few mock APs where kids get 0 out of 9. Some kids just skip it, free response. Not the whole thing. I don't let them do that or else I won't pass even my class. But where they get 0 out of 9 because they just made so many mistakes. Even if they put some like good forever cards down, it didn't apply, or they made a mistake somewhere that took away the point they would have gotten. So it actually still is a feat to get 4 out of 9. That's still good, but anyway, they explain why they graded, what they graded, and exactly how the kid got 1 out of 2 points, or 2 out of 3 points, or 3 out of 3 points, and they explain that. So anyway, there is a lot of analysis as far as questions. Does that make sense, guys? So let's go ahead and check out. We can check out the answer key, but we can also check out maybe like the 9 out of 9 and see what that kid did and see if we would have done the same. Okay? So for letter A, did you guys figure out that the relative maximums are every time the graph goes from above, the derivative being positive, to below, the derivative being negative, which happens at -3 and at 4. Now they say, wait, why did they put 1? They found the critical numbers first, the intercepts, boom and boom and boom. They could have technically done the endpoints, except this says don't include the endpoints. So then they said f prime changes from positive to negative at -3 and 4, therefore f has a relative maximum. They didn't put the first derivative test. They didn't put the relative extrema according to the first derivative test. They just showed why. So the relative extrema, -3 and 4. Let's see what the kid did. All right, what'd you do? They said there's a relative max at -3 and 4. The graph of f prime changes from positive to negative. I've seen kids put a little plus and put a little minus. Totally works. Which hints, interesting, the graph of f changes from increasing to decreasing at those points, relative maximums. Did they put down all the critical numbers? Nope. Did they get all the points? Yes. Because they said, I know, and then they went ahead and said f prime changes from positive to negative, f changes from increasing to decreasing. How many of you guys would have gotten at least one of those 2 points? You figured out where they were. Good. Keep your hands up if you're like, I think I could have gotten the justification. Cool. The rest of you guys, do we know now? Remember, relative extrema, we look for critical numbers, but this is the graph of who? F prime. So critical numbers, aren't they zeros and DNEs? Are there any DNEs, any vertical asymptotes or holes? No. Okay, so we look for the zeros. -5. Oh, it says don't include -5. It's just greater than. 0, 0, 0. But we're looking at which of the critical numbers, which of the zeros of f prime have f prime changing from positive to negative, which means numbers above to numbers below. So that means for letter B, if you guys didn't get letter A, you probably would have been lost on letter B. But letter B has us looking at which derivative. I heard you guys talking about it. Second derivative. But wait a minute, this is the graph of the first derivative. When you're given a graph of the first derivative, how do you think of f? Area. 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 Changes in the original function, f of b minus f of a, will be area. How do I think of f prime? Y values, above, below. How do I think of f double prime? Slopes. Where f prime is increasing, who would be positive? F double prime, because f prime's prime. Where f prime is increasing, f double prime is positive. Where f prime is decreasing, f double prime is negative. F double prime is positive. F double prime is negative. What needs to happen for an actual inflection point? Did you see where f double prime changed? Where did it change? At -4, because f prime changed from increasing to decreasing. At -1 and at, got it. So let's go see what they put. At -4, -1, and 2. Why? They said f prime changes from increasing to decreasing or vice versa at the points. They weren't even super specific talking about every single one. They just said f prime changes from increasing to decreasing or vice versa. Therefore, points of inflection. Let's see what little 9 out of 9 kid did. No, I've never actually seen someone's writing that was my own kid, but I always wonder. Points of inflection, -4, -1, 2. At the, okay, they got the right answer. F prime changes from increasing to decreasing or decreasing to increasing, which hints at the points. F changes from concave up to concave down or concave down to concave up. What did they not say that some of you might have thought of saying that would have also been okay? F prime changing, increasing to decreasing, or vice versa. F changing to concavity, or vice versa. What else could they have said? F double prime changes sign. You have to be very particular with how you say it. But all these things mean the same thing. F changes concavity because F prime changes increase to decrease or vice versa. Or you could have also said F double prime changes signs. It might be nicer to say something about because the slope changes of the graph or the slopes of F prime, aka F double prime, change sign. But do you guys see how these points aren't impossible to get? But you have to know how to read the graph and how to use your forevers. Okay, what was letter C? Sorry, I want to see hands. How many people at least got the right points for that one? Oh, no, it's okay. You got at least one or two. Let's do that. Got at least one or two. Okay. Letter C. Ooh, wait a minute. We just talked about this kind of, didn't we? So when will F be concave up, first of all? F prime is increasing, aka F double prime is positive. All good ways of saying it. So where is F prime increasing? -5 to -4, right? -1 to 2. Now here's the question. Would you guys have closed the -5? The -4 you should have kept open because isn't F prime 0 here because it's flat? I should say F double prime. F double prime is 0 here. F double prime is not positive. F double prime is 0 here. Shouldn't include it in the interval. F double prime, wait, what is F double prime at a sharp point? What's the slope at a sharp point? Sharp points and vertical tangent lines. What's going on with derivatives? They do not exist. Okay, whew, that was scary. So F double prime doesn't exist, shouldn't be included. F double prime 0 shouldn't be included. F double prime 0 shouldn't be included. But what's F double prime at -5? Isn't it up? Isn't the slope up at -5? It's not flat. It's not DNE. So let's check out their intervals and see what they did. Ooh, did they include -5? No. I wonder if you could have, though, because technically there's actually been some debate the last few years, and this one was a while ago. I think now they would include this one. Some teachers just teach their kids always open intervals. That's why I think they were putting that answer. And they didn't technically say in between -5 to 5. Let's go see what 9 out of 9 kid did. Let's see how smart he was. No, check it, though. Check it. What did he do? He did make it look iffy. Did he include? I don't know. Maybe he just made it look iffy. I thought he put in or equal to, but maybe not. Let me see what the next kid did. Oh, he just kept it open like his teacher told him to. Good job. What did this kid do? Well, no. Actually, he didn't do too bad, though, right? Yeah, he didn't do the little X with the little psh, 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 and he didn't put any words. Like, okay, but he got 4 points. He got something somewhere in this. Okay. Let's come back. So what did 9 out of 9 kid do? Yeah. But wasn't he really just saying his forever card? F is concave up and has a positive slope. The graph of F prime. Talks about increasing. With concave up, F prime increasing. The slope of F is positive. F double prime. Okay, so he has now we didn't look at the second part of the question. We just looked at the concave up. But he says concave up, he says why is because F prime is increasing. And then down here, F prime is increasing means positive F double prime, which is concave up. It was kind of convoluted. But let's go back. There was a second part to that question. What was the second part of the question? Concave up and positive slope. Positive slope. Who's the slope of a graph? Is it F prime, or F double prime? Well, the slope of this guy is F double prime, but just the slope of F. Isn't that F prime? So even though we said the intervals would be -5 to -4, oh, this is why it's open. -5 to -4. If it was just concave up, there should have been a closed interval at -5. But it also says positive slope, which means the values of F prime need to be above. Hey, what's the value of F prime at -5? 0. Oh, that's not a positive number. That's why they didn't include it. But everywhere here, F prime is positive and increasing. Over here, from 1 to 2, F prime is positive and increasing. We can't include from -1 to 1 because F prime is negative, which means the graph would have, F would have a negative slope. So that's why -5 to -4, and that's why 1 to 2. Find the absolute min. Ooh, this one's a little rough. We're going to talk more about this one as we go on, but just really quickly, did anybody figure out where the absolute min was? The final answer is at 1. At 1. Why? Could you guys find this little semicircular area? And could you, starting from the initial point, could you say, hey, between -5 and -3, wait, so starting at 1. Bummer. We know at 1, the thingamabob, the position is at 3. We could go from 1 to 4 and add to see how far right he moved, and then we could subtract to see how far left he moved. But either way, this guy moves right a lot, left a little. And then as you go backwards, backwards from 3. He moved left to get to 3, which means moving backwards, we're actually moving right. So you would move right all this area, which would put you above 3 again, and then you would move left a little bit. Long story short, if you're thinking about position, if you're at 3 and you move a lot right and a little left, this is your lowest position. And then if you move backwards, which is really moving to the right and to the left. Anyway, we'll talk about this with math. They do some definite integrals. They do something we call integration as net change, which we'll do a worksheet on this next chapter. But kiddos, the AP guys love to do FRQs like this. Not every year, but pretty frequently. So we'll see more of these as we go on. I just wanted to show one of them to you guys. In years past, we've actually had like a whole FRQ session before the test, and then you would have had an FRQ on the test. But this year, we kind of just did the short and sweet version. Do you see what I mean by there being tons of FRQs out there? Lots of analysis for every single FRQ that is out there? Anyway, something for you to think about as the AP gets closer and as you figure out which problems you're strong on and weak on. But for right now, we are going to chapter 4B. It's almost as good as 2B, or not 2B, but it's not. 4B. Although you guys are in Hamlet now. Aren't you? Seniors.
I don't know where our class is.
Oh, never mind. Maybe you're not in Hamlet. I thought you were in Hamlet. You watching the movie? Which one? The Mel Gibson one? Oh, no. The Mel Gibson one's Macbeth. Probably the Kenneth Branagh one. Yeah? He's excellent. Thank you for clarifying. I'm recording. So yeah. I totally did. Michael, go get one too. All right. There's still a good number in there. We are in chapter 4B. Title of the chapter, if you guys are titling it, I would call it More Integration, because it is. Hey. Guess what? Calculus BC has a whole chapter that's more integration. So there's a lot out there, but we're just doing a little bit more. This is going to be the most practical integration section of the year, which we only do integration second semester, so it's not really that exciting. But those of you guys that have come to me asking for AP questions in integration, I've had to give you like Riemann sum ones, because some people come asking for multiple choice questions for their European stamp, etc. I've had to be very, very picky and choosy. I can't just give you everything because you hadn't learned integration yet. This one is called More Integration Techniques. That's totally fine. We are going to take, I think, actually 3 days on it. I just posted your Google Classroom homework. I don't think it's Monday. However, the big thing that we need to learn is U sub. U sub. Because we're going to learn how to go backwards on the chain rule. However, before you learn U sub, before you learn how to go backwards on the chain rule, how would you, if you had seen this integral on the test, how would you have had to solve it? I told you there is no multiplication rule, there is no division rule, and I am right. There is no multiplication rule, there is no division rule, and man, there's so many lights turned on right now. How would you have had to do it? FOIL. Some of you would have killed puppies. Oh, algebra. However, Let's assume we can FOIL. We're in calculus, right? When you FOIL, you would get 25x to the fourth plus 10x squared plus 1. Oh, but what do we still have? Are we good? We're not killing puppies? Oh, I can zoom in. Sorry, Rachel. 5x squared plus 1 times 5x squared plus 1. First outer, inner, last. The outer and the inner ends up doubling. The multiplication of the two. Then couldn't we keep going and multiply the 10? And so we get 250 x to the fifth plus 100 x cubed plus 10x. But what do we still have to do? Integrate. So isn't that going to be 250 x to the sixth all over 6 plus 100 x to the fourth over 4 plus 10x squared over 2 plus c. Is this wrong? No. But would it match? Because here's what the AP would have and expect you to match it with. No idea what letter it is, so I'm not going to put that. But instead, what I could do is say, oh, hey, oh, stink. What would you have to do to go from there to there? Simplify, 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 pull out an x squared, and then hopefully be able to factor stuff? And even then, it wouldn't work. So we have to, now, that's not to say that sometimes you don't just have to multiply and go for it. And if worst comes to worst, couldn't you guys have taken all their multiple choice and multiplied them all out and see which one kind of matches? But be careful, because this guy's plus c might be different than that guy's plus c, and so this might have some constants that get absorbed to become that. That gets a little rough. But what did I do? And what did I see? Another way of looking at it. What did I do and what did I see? Now, just a quick warning. If I teach BC, and if BC is doing a lot of integration mental math style, you shouldn't necessarily be making the same jumps that I do every now and then, like right now, how I was like, oh, hey, this is the answer, no big deal. I would never want any of you to make that jump. Maybe in BC, but not now. So first of all, I don't want to give you unrealistic expectations. There is some work to do to get to the answer I just showed you. And it takes time to master it to the extent where every time you could do this type of integral, mental math style, and never make a mistake. This just happens to be a really easy one. But we're going to deal with, or we're going to get new techniques for integrating complex. I don't mean like imaginary numbers. So let me go change this. Hold on. Man, so many English words have math meanings. Complicated. There you go. Functions, specifically composite functions. We've seen the derivative of f of g of x is f prime of g of x times g prime of x, chain rule. We've seen the derivative of f of u is f prime of u times u prime, chain rule. So can we possibly look at something in an integral and say, I think you came from a chain rule? Yes, indeed, we can. Given a function f and its antiderivative capital F, if they choose to use those letters, we've seen they like to just change up the letters on us. The integral of f of g of x times g prime of x dx is equal to, remember, if he's an original function inside an integral, I'm looking for his antiderivative. This notation is taking me back the same way this would take me back. So in integrals, there might be a piece that is there that all was a part of the u prime. There might be a piece that was there that was all a part of the u prime. trying to think if there's a better way I want to show this. We did at one point talk about how to get dy dx. We needed dy du times du dx. Does that help you? I don't think so. I don't think so. I was going to try and help you with some of the notation, but I don't think I will. We'll stay here. Now, guys, this is a theorem. I guess I could technically have you guys write this down, but the point is it's very, 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 very rare that whatever we're given perfectly matches this. This is one of those very, very, very rare examples, which is why I had him be our introduction example, or had someone like him be the introduction example for this section. What do you guys see when you look at this integral? If you're trying to think about, oh, hey, this can be true. That's a nasty fat circle. Let me get a nice thin one so it doesn't distract. There we go. What do you guys see? That's a u prime dx. When? What's the u? U is equal to 5x plus 1, 5x squared plus 1. U prime would equal 10x. So 10x was just the u prime for a u that was 5x squared plus 1. What do you think I can do if I can rewrite this guy to be like, oh, hey, so you're just an f of u times u prime dx? So I could rewrite u to be u squared times u prime dx? Yep. Do you guys see why I put my answer as 1/3 u cubed plus c? If I can go from an integrand that has a u prime dx, ignoring the u prime dx, and then go back, well, that wasn't too bad. But here's the problem. The notation is really, really messy and really, really nasty because you have u's and x's, and we're not supposed to have that in integrals. That's illegal. So even though this is true, let me go ahead and rewrite this in a way that is legal. The legal way to do it, let me zoom in real fast, is instead of writing u prime as dx, which is totally true, taking this little guy for just a second and saying, okay, hold on. That's not working out very well, is it? Taking this little guy and saying, okay, isn't u prime du dx? So can I actually rewrite this to be du as 10x dx? Because I can move him on the other side. Now see what I can do. Now I can go ahead and say, all right, I know I have a u squared u prime dx, but I can rewrite this guy to instead be the integral of u squared, and all of that becomes du. Oh my goodness, what was once a mess is now so nice and short and sweet and simple. Guys, if you were to be given that without knowing any of the backstory, what would you do? Just antiderive it because everything matches. It's totally legal. So 1/3 u cubed plus c. But hold on, am I supposed to have u's at the end of this problem? No. So what do you think the last step is? Who is u? Plug it in, plug it in. Done. I did all that in my head. Yeah, wasn't too bad. Let's practice. Or at least, let's go a little further, a little deeper in. Oh, back to, we already went back. Forget that. Now what? U sub steps. U sub steps. Do you remember how when we were doing derivatives, it took some time and some practice to look at a function and be like, oh no, I need chain rule. Oh no, I need product rule. Oh no, I need quotient rule. Oh no, I need, well, trig rules were kind of obvious. There's trig staring you in the face, but I need to rewrite square roots to be fractional powers. It took time for you guys to like be able to look at a problem that you need to take a derivative of and have your brain automatically jump to the steps you're supposed to do. It took time. It took practice. It's going to be the same thing here. But here are the basic steps for U sub. Ironically, it's not going to be a forever card because we need this to be mechanical, not memorized, not something you go back and start regurgitating steps. That's not going to help you. A lot of practice is going to help. A lot of making mistakes and then fixing them. Making notes about the mistakes that you're making. So don't worry, we're not going to make this a forever card. But it would be something good to have near you as you're playing around with homework. Just to reference. Let U equal the inner function. Inner, oh yeah, chain rule. U was always the inner guy. Choose wisely, that's going to take time because you guys don't have wisdom with U sub and integration. I literally just showed it to you. So the wisdom thing, it's going to take time, but that's okay. Wisdom always does, doesn't it? Oh, life lesson in there somewhere. So choosing wisely, don't worry. We'll develop that, hopefully. If you guys hang in there and don't give up on me and don't stop doing your homework. Some of you catch up. We're on a new chapter. Start afresh. Number 2, find du. Wait, but find du, I don't get, oh, du comes from u prime. Du comes from u prime. If it helps, you guys can take this little clue one step further. U prime is equal to du dx, so take it one step further. I think some of you would be helpful to see this now. Which means dx is equal to du over u prime. When I'm saying find du, what I'm actually meaning is you want to get the integral rewritten in terms of u and du. So to get du, find u prime, multiply them by dx. But then we almost always are going to want to get dx alone because of the step down here. Every integral will have a dx. So if we can get this little expression, we can plug in for dx, and we're well on our way to rewriting for step 3. So when I mean rewriting, we're going to need for that du to plug in for dx. Hopefully, step number 4, you have this nice little integral. Hopefully, you have this nice little integral in terms of, in step 3, an f of u du. And he's going to be nice. Once you have them all nice and rewritten, only u's and then du. All the x's, all the dx's are gone. If you have x bounds, they're gone too. Find the antiderivative. Hopefully it's something that you can do. And at the very, very end, replace u with its function. Don't forget to plug back in. U is equal to whoever he is. We can call him g of x, but plug back in, get it in terms of x's. Once again, to finish off the problem, and don't forget your plus c. Don't forget your plus c. So I'm going to underline this in yellow just because it is important, but I'm not going to put a yellow box because then everybody thinks it's a forever card, and then we're just in trouble because it's not a forever card. Let's see some easy examples to end off today. Easy examples? Yep, because u prime fits perfectly. Who do you guys think your inner function is for number 1? Yeah. X squared minus 10. So write them down. U is equal to x squared minus 10. Choose u. Choose him wisely. He's the innermost. He's stuck in a square root. Well, if u is equal to x squared minus 10, we could write right now du dx, which is u prime, equals 2x. And then we could multiply both sides by dx. But do you guys get that we're going to always be multiplying the other side by dx? It's a shortcut if you do write u prime equals du dx, and let's multiply by dx. It's a shortcut if you just say, oh, so derivative of u is 1 du. dx I'm sending to the other side. And what's the derivative of x squared minus 10? It's just a shortcut. I'm doing u prime. I really am. I'm just shortcutting it and not writing this whole like u prime is du dx. Let's multiply the dx on the other side. Sure. Miss Sutherland?
Yeah.
Okay. Now, what did I say to do as we start to rewrite, guys? What do we solve for? Once we have the u prime? Yeah. So we're going to go ahead and take the u prime by doing du is equal to, let me move this all squish, 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 squish. But as soon as you have this expression, we're going to go ahead and get dx alone. Why? Because I need to plug in for him, and he's right there. So dx is equal to du over 2x. Why does u prime fit exactly? Because when I go to plug in, I have a 2x there. I have a square root of, oh, hey, isn't he just u? And then I can substitute dx for du over 2x. Anytime u prime fits exactly, guess what happens right away? All that extra stuff is gone. U prime was the only extra stuff. 2x dx was just u prime. Oh, I can ignore him. So when u prime fits exactly, when you go to plug in your expression for dx, everything extra goes away. After you put in the u, you're ready to go. So how do we integrate, guys? Oh, you know. Square root, we can rewrite it to be what? Good, u to the 1/2. Isn't that going to be 2/3 plus c, and to finish this off, 2/3. Who's u? You know us. We're going to have to probably practice simplifying, making it match, rewriting, blah, 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 blah. But that's the right answer. I did the power real quick. Are we okay? Ish? Even though I went a little fast? Some of you are already pondering number 2. Oh, but it has trig. Okay, you have to choose wisely. Who's the innermost? Secant tangent. No, because one's cubed and one's squared. We can't do that. Secant? Part of developing the wisdom in these is going to be realizing you leave him alone. Who's the innermost? Tangent. Be like, I have no idea why. Go on, Faith, just for a sec, okay? When I go to du prime, on the other side, what's the derivative of tangent? See why I left the secant squared? I wanted him to stay because he's my u prime. As soon as we have this, we take our dx, get him alone because we have to plug in. Dx is equal to du over secant squared. I come up here and I say, who's cubed? U's cubed. Well, tangent's cubed. Then I have my secant squared. Why is this one a nice person? Ha! Got it. So what am I really integrating? U cubed, aka 1/4 u to the 4th plus c, aka 1/4. Don't get tricked by the... Bye, Dylan. You guys have seen? Well, just the beginning, scratching the surface. But we're going to play more tomorrow, so if I were you guys, as soon as we start USEB, as soon as we start the calc section, see how far you can get in homework. Bye, cool kids. But I think just a few of you, our procedure won't change, just what happens changes. Bye, guys. Good job, good job.